So let's deal with relative velocity questions. Example 43. Example 43 in Aurora. A car A is moving with a speed of 10 meter per second on a straight road and is ahead of car B, which is going in the same direction at the speed of 6 meter per second. Find the relative velocity of A with respect to B will be VA minus VB. VA is also positive, VB is also positive because both of them are towards the right side. And so then therefore it's 10 minus 6 is 4 meter per second. They ask you B with respect to A. It will be like a VB minus VA, which will be 6 minus 10. So the answer will be minus 4 meter per second. Okay, so then that's what it is. And let's go to the next question. This negative sign just shows that the driver in car A, when you look back at car B, that's lagging behind. So just to show that with respect to A, so driver in car A looks at B, it seems to be lagging behind, and that's what it says as minus 4. Let's go to example 44. On a parallel rail tracks run north to south. So this is north and this is south. And two parallel rail tracks, this is north to south again. There is a train A which is moving towards the north with a speed of 54 km per hour. Moment I see 54, I can write by 5 by 18, which is therefore 15 meter per second. And there is a car B which is moving towards the south with the speed of 90 km per hour. So 90 into 5 by 18 is 25 meter per second. But I would write it as minus 25 meter per second without forgetting, because if this is going to be, the A is going to be taken as positive velocity, the B's velocity should be taken as negative because the direction is reversed. So thus you know A and B's velocity. What is the relative velocity of B with respect to A? Is VB minus VA. As you know, VB is minus 25 minus VA is positive, which is just 15. So the answer is minus 40 meter per second. So as you can see, from A, you're looking at B. So from sitting in A and looking at B, you know that the B is going in the other direction. It's going in the other direction. That shows that this is minus 40 meter per second. So then okay, so the next question is the second part of the question, where they're asking relative velocity of the ground with respect to B is VG minus VB. Relative velocity of the ground with respect to B, VG is always 0. Ground is actually not moving, it is only appearing to move. Minus VB is the velocity which is of B's, which is minus 25. So it's plus 25 meter per second. It makes sense because when a train is moving in this direction, the ground will appear to move in this direction. So this direction is taken as positive, and so plus 25 makes sense. So let's go to next question. It's the third subdivision. Supposing there's a monkey, there is a monkey on this train. There's a monkey on this train which is going in this direction. Okay, and they're given the relative velocity of the monkey with respect to train A is 18 km per hour. 18 km per hour is 18 into 5 by 18, which is 5 meter per second. And you have to take it as minus 5 meter per second because the monkey is going in this direction, downward direction. And the relative velocity, let's do monkey with respect to A, is monkey minus velocity of A. You don't know the velocity of the monkey, but you know the relative velocity of monkey with respect to A is minus 5. Velocity of the monkey minus velocity of A, the train A is just going upwards, so 15. Velocity of the monkey therefore is minus 5 plus 15, which is 10 meter per second. It happens to be the actual velocity of the monkey as observed by a person standing on the ground. Like this is the actual velocity of the monkey. So then that completes it. And why is it not no negative sign? Because when a person is seeing it from the ground, it's not with respect to train A for you to say it as negative. I hope you understood. So let's go to next question. Is the example 45. Example 45, two trains 120 meter and 80 meter long. There's a train which is 120 meter long, another train which is 80 meter long. They both are going with each one going with the speed of 42 km per hour, and this is going at the speed of 30 km per hour. They're going in the opposite direction, so you know you have to add and what time they will completely cross each other. So for this train, I'll just mark it in red color, to come here. The driver sits here and the guard sits here. For the driver to come here and the guard to be here. Or in other words, for the guard of the second train to cross the guard of the first train. Okay, so then which means this train has to cover 120 meter plus in addition this 80 meter. The total distance that this train has to cover is 200 meters. That will be the total distance. And the relative velocity is addition. The velocity of the train B with respect to A or B with respect to B is always under addition, which will be 42 plus 30. So it will be 72 kilometer per hour. If you want to convert meter per second, 5 by 18, 18 fours are 32, yeah, so 5 fours are 20 meter per second. Thus you get your relative velocity to be 20 meter per second, and the time taken is total distance by total time taken, total distance by total velocity, total relative velocity. Okay, once again hold on. So total distance itself is 200 by total relative velocity is 20, so the answer is 10 seconds. 10 seconds is the answer. That's when this train B is, let's call this train A, train B. Train B is able to completely cross train A. Okay, so let's go to 46th example. This is the Titanic sum. Let's name it as a Titanic sum. Titanic sum where there is a rescue boat. The speed of the rescue boat in still water. In still water, it's capable of going in 7 meters per second. Okay, in still water. But however, the boat will not go in still water. No, the boat is supposed to go only in, we are not going to run the boat in a swimming pool. The boat is going to go only in running water. So then there is a stream in which the water is running in this direction with a speed of 3 meters per second. And the boat is going to go upstream. So let's take this boat. This is called, let's call it as a rescue boat. The rescue boat which has come to rescue Jack and Rose in Titanic movie. It's going to go upstream now, and in the upstream that it's different concept, because when the boat is, you can't just add this velocity because the boat's speed is going to get reduced. Water is pushing it in the opposite direction. Boat is going with the speed of 7 meters per second upstream. The net velocity of the boat with respect to water will be 7 minus 3, which is 4 meters per second, and it's going to travel upstream till a distance of 4.2 kilometer, which is 4,200 meters. It's going to travel this distance and then take a U-turn and come back, and on the way, when the moment the boat is in the water, it's dropping a float. It's dropping a float for rescuing Jack and Rose, and the float tends to move in the speed of the water. So the velocity of the float will be just 3 meters per second, just the velocity of the water. Here is the velocity of the relative velocity of the boat with respect to water I have written, and it's traveling 4,200 meters. The time taken for it to cover this distance, 4,200 by 4 is 1,050 seconds is the time taken for covering this distance onward journey upstream, the upstream. Then it's going to take a U-turn and come back towards a float. But in this time, simultaneously in this 1,050 seconds, the float carrying a velocity would have moved through a distance of velocity into time, which is 3 into 1,050, which will be 3150 meters. So this float would have been moved through 3,150 meters. Now when this is going to take a U-turn and come, it's going to travel this distance plus this distance. So the total distance covered now by the rescue boat which is coming back is 4,200 plus 3,150, which together 7,350 meters is the total distance it has to cover in the return journey to come closer to the float, to reach the float. And so this is the distance, and you want to find, the question is, how long will it take for the launch to reach the float? The time taken to cover this distance, time is equal to distance by velocity, where the velocity for the downstream, look at this downstream, for this journey, the water is also going in this direction, boat is also going in this direction, so it's velocity of the boat plus velocity of the water, which is the original velocity of the boat is 7 plus velocity of water. And look at the float. The float is already going with the velocity of the water. So in both the cases, let's cancel off the velocity of the water in both the cases. Let's consider that the float is not moving. Let's consider the boat is moving with the original velocity 7 meter per second. So then therefore you can divide it by 7 and you get another 1050 seconds. So the total time taken for the rescue boat to go 4200 towards the left and then come back and catch up with the float will be total time T1 plus let's take it as T2, let's take it as T1. 1050 plus 1050, so total time is 2100 seconds. In terms of minutes, they would have written it as 35 minutes, and that's a sum. So let's go to a very, very beautiful sum. So 47th question. So the 47th question, a jet plane traveling on a speed of, or let's do a jet plane, it's traveling with a speed of 500 kilometer per hour. Ejects a combustion. The gas here is getting combusted and the gas comes outside through, and this is coming with the relative velocity of the gas with respect to jet has been given 1500 kilometer per hour. And you know that with respect to jet, if you're sitting in the jet and looking at the gas coming out, it will be minus direction. Never forget to write that. And VGJ is velocity of the gas minus velocity of the jet. Velocity of the gas you don't know. You know the velocity of the jet with respect to gas with respect to jet, you know, is this, and velocity of the jet itself is 500. So velocity of the gas is minus 1500 plus 500. It's minus 1000 kilometer per hour. It's velocity of the gas, and obviously the negative sign will be there because you're looking at the gas sitting inside the jet and it's going in the opposite direction. So it makes sense. It's another sum which is very important. Let's go to 48th question. The train A and B are of length. Okay, there is a train A which is of length 400 meter, and another train which is going at a uniform speed of okay, and there's also another train B. The driver of B decides to overtake A. Okay, so then I have to draw it little properly because this is my train A, whose 400 meters is the length of the train. It's going at a speed of 72 kilometer per hour. Okay, and there is a train B, and the train B is also the same length 400 meter. And that is also going at a speed of 72 km per hour only. But there is an initial distance between the train A and train B, because the question is find the initial distance between A and B. So there is a distance between A and B, which you can call it as x. Now the train B decides to accelerate. The acceleration is 1 meter per second square and tries to overtake A, which means the train B has to come here. That is, the guard of the train B has to overtake the driver of the train A. So then therefore the train B has to travel a distance of x plus this 400 plus an additional 400. So therefore there is 800 plus x is the total distance to be covered by the train. But you know that the train is accelerating, and so you can write s is equal to ut plus half at square, where s itself is 800 plus x. The relative velocity, both the trains are initially going at the same velocities. When you subtract them, it will become 0. And acceleration is 1 into time. They've given in the question, the time taken for this overtaking is 50 seconds. So 80 plus x is equal to half into 50 into 50. So then therefore 80 plus x is equal to 25 5 is 1250. X itself is 1250. 1250 minus 80, is it? And what am I getting? It's 0, 15, this is 7, this is 1, 1170 is my x, initial distance. 50 plus half 80 square, this itself is 1050, but this is actually covering a distance of 80 plus x according to me. Initial relative velocity being 0, I get this as answer, but I get it as equated to 80 plus x. So my x will be only 1170 meters, whereas Aurora shows it differently. I would like you all to check what could be wrong, whether Aurora has made a mistake or something wrong with the way we have done. We have definitely taken it as 800 plus. What's the original distance? The original distance is only about x. So just think about this sum and identify. If there is any mistake, you can come back to me, but this is the way I would think of doing this sum. Example 49. On a 2-lane road, there is a car A which is traveling with a speed of 36 km per hour. There is a car B and a car C which are directly approaching car A in the opposite direction. The initial distance between them is 1 km, and here also it's 1 km. The car B is approaching in the opposite direction. Both of them are approaching with the speed of 54 km per hour. This is also coming with the speed of 54 km per hour. Now car B decides to overtake car A before C comes and collides with it. Before C is able to come here. So split it into two. Okay, and you have to find the relative velocity of C with respect to B. What is C with respect to A? I'm sorry, they're coming in the opposite direction, so then the velocities will get added. 54, let's convert into meter per second, because 36 into 5 by 18 is 10 meter per second, and 54 into 5 by 18 is 15 meter per second. So this is 10 and this is 15, both of them are going to get added. It's 25 meter per second is the relative velocity, and the distance is 1000 meters, 1 kilometer, which is distance itself is 1000 meters. So time taken for this journey is 1000 by 25, and 25 40 seconds is the time taken for this journey. Okay, so then therefore let's come back to this left hand side. Before this 40 seconds or at 40 seconds, this should come here. Let's take the time to be 40. You know that this car B's acceleration is what you want to find. We can take S is equal to ut plus half at square. The relative velocity between B and A, they both are going in the same direction, so then therefore you have to subtract, and 54 is nothing but 15 meter per second. This is 10 meter per second, so when you subtract 15 minus 5, it will be 10 meter per second is the relative velocity of B with respect to A. So then that will be the initial relative velocity, because after that it's eventually going to accelerate. So 10 into time taken, it has to take the same time as this 40, and plus half into acceleration is you have to find, and t square is 40 the whole square is equal to S, and S is that distance which is again 1000 meters. From this we can find what is the acceleration. So let's see if you are able to get the answer. So then here did we substitute the relative velocity? We know this is 10, this is not 5, this is 10, and so the relative velocity is 5 meter per second, and so this is 5. Okay, I'm sorry about that. The 1000 therefore is equal to 5 4 20, 200 plus half into A into 40 into 20, cancelling this. And so you get this can go to this side, it will become 800 is equal to A into 800. So you get A to be 1 meter per second square, and that it has to go in this acceleration or more an acceleration than this, because time can be 40 seconds or less than 40 seconds, so that they don't meet with an accident. So let's go to example 50. Example 50, two towns, there is a town A and there is a town B. The regular buses ply from either directions in a time of t minutes. From this bus stand, for every t minutes there is a bus. From this bus stand also, there is for every t minutes there is a bus. Both of them, all buses are going always with the velocity v only. There is a cyclist who is going in this direction from A to B, and he notices a bus coming past him every 18 minutes in this direction and every 6 minutes in the opposite direction. So which means you have to take the sum and divide it into 2 in the cyclist perspective. Cyclist is going with a velocity of 20 kilometer per hour. So this is 20 kilometer per hour. This bus is also going in the same direction, cyclist is also going in the same direction. So it will be v minus 20. And the time at which he gets to C is 18 minutes, which is 18 by 60 if you want in seconds. Minutes convert into seconds. On this side, if you see from the bus stand's point of view, the velocity is v and the total time taken is t, and both of this can be equated. T by 60, 60, 60 anyway gets cancelled. So thus you get Vt is equal to v minus 20 into 18, you get equation 1. Similarly, you go to the right hand side and do the sum. The cyclist point of view, you know that the bus is coming in the opposite direction, so the velocity will get added v plus 20 into t by 60 is equal to bus stand point of view. The bus is leaving has a velocity t and the time is t. Again t by 60, 60, 60 get cancelled. So you get a v plus 20 into t is equal to v into t. Both of them are just vt, first equation, second equation, so you can equate them. So v minus 20 into 18 is equal to v plus 20 into, he notices it in every 6 minutes, right? So you can write it as 6. 6 3s are 18. 3v minus 60 is equal to v plus 20. v taken that side, 2v is equal to 80, v is equal to 40 meter per second, kilometer per hour, sorry, kilometer per hour, because anyway the kilometer per hour is the speed? No, yeah, this initial speed is taken to be kilometer per hour. Even though these are all in meter per second or minutes or whatever, but they are the ratios which have got cancelled, so the answer will still be in kilometer per hour. That is the initial velocity. You take it and substitute in any one of the equations, you can find the time. So v is 40 plus 20 into 6 is equal to v is 40 into t. From this, if you are taking it here, you can say that this will be 60 into 6 is equal to 40 into t, 0 0 get cancelled. 36 is equal to 40, t is equal to 9 4s or 36. So 9 hours. 9 hours? 9 minutes. 9 minutes. So because the timing was which is specified in the question was only t minutes. So we got the t and that's in 9 minutes. Okay. So that's a sum. So let's go to next question. Next question is the example 51. On a long horizontal moving belt, there's a belt which keeps moving from left to right like this. A child is running to and fro at a speed of 9 km per hour is the actual speed of the child. Between the parents, the father is here and say the mother is here. She's wearing a sari. So the child runs between the father and the mother. This is mother and this is the father. And the speed of the, okay, now the belt is moving at a speed of 4 km per hour. The child is moving at a speed of 9 km per hour. Both of them in this case is running in the same direction. So then you eventually subtract the turn. So you get 9 minus 4 is the relative velocity of the child with respect to belt, which is 5 km per hour. And next is, this is the first case where the child is taken to be running in the same direction as the belt. If the child is running in the opposite direction towards the mother, the velocity of the child with respect to belt will be, you have to add it, child running in the opposite direction to that of the belt. Okay, so in this, I'm saying it wrongly. Can you see? If the child is going to run along the belt direction, already belt is running like this, child is also running, is going to reach the father faster, which means the velocity is going to get added. I'm sorry. So you have to think of it practically, not like a train. Okay, it's 13 km per hour. If the child is running in the same direction as the belt, the child is running in the opposite direction of the belt. You know, the child is going to run like this. It's going to get pulled down by the belt always, and so the velocity is getting reduced. 9 minus 4 is 5 km per hour. So just write this, and you look at this child with respect to belt. You look at it from the moving belt. The child is going to be in the opposite direction. So ideally you must put a minus here. Oh, but Aurora has not done that. Okay, just leave it like this. Now the next question is the speed of the child with respect to either parent. See, for the third question, the parent is also moving with the velocity of the belt, and both the parents are moving with the velocity of the belt. So if supposing, so the child is also going to be moving with the velocity of the belt. So velocity of the belt can be cancelled everywhere. You can consider the parent to be just static with no velocity. The child is having the actual velocity of 9 km per hour. So then velocity of the child with respect to either parent, ignoring the velocity of the belt in every place, you get it to be 9 km per hour, which is 9 into 5 by 18, which is 2.5 meter per second. Velocity of the child, I don't have to put negative because either parent. And the time taken for the child to cover the distance of 50 meters. The parents, both the parents are 50 meters away. Time is total distance by the velocity, which is the velocity of the child with regard to either parent. So then 20 seconds. This is a question, very very important question. Please learn it. I can send you the pictures scanned. You all must buy Aurora so that you can learn these sums properly. Okay. So these cover the relative velocity questions.